everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about the Haber process. I hope you guys do find this interesting and useful for your GCSE studies. If you do, feel free to let me know by giving the video a thumbs up. You can also comment in the comment sections. Thank you so much to everyone's support on my videos. I am really enjoying reading through your comments. It's lovely to hear from you, so thank you ever so much. If you know of anyone, maybe a friend, family member, someone in your class who you think these videos would help as well, definitely feel free to share this with them and they can join this community. And speaking of joining communities, if you haven't already, please do subscribe. Thank you so much for your support and time. Let's get started. So if we go back to the 1900s, specifically 1909, this is when the Haber process became a process, and it's because of a scientist called Fritz Haber. Now, he got a Nobel Prize actually after World War One in 1931, and this was for ammonia production, or something called nitrogen fixation. A lot of the chemical work that he did supported this work with the Haber process, and he did get credited for that work. He did also work with another scientist called Bosch, who is actually a relative of the person who makes a lot of the products we see now, like the Hoovers and other electrical devices. But essentially, Fritz Haber was highly criticized for his work on the Haber process, especially after World War One. And this is because the Haber process is used to make ammonia from nitrogen and hydrogen. And that is used to make, like I said, ammonia, but that specifically, that chemical can be used to make fertilizers, which was really useful at the time because obviously with a world war and rationing, agricultural crops could be grown on a mass scale for industry purposes and obviously supporting the wider community. However, Fritz Haber did get a lot of criticism, as I say, because unfortunately ammonia was used in the war effort to make poisonous gases, to make explosives as well, specifically for the Germans. So this was obviously leading to a lot of tragic deaths, and that's why he gets quite a negative light on him. But the Haber process itself can be used to make fertilizers, which is what we want to focus on at GCSE. But I thought it'd be worth mentioning because some of you guys may be studying GCSE history, and I think to kind of help us understand where everything works together in GCSE, lots of subjects working together, it's quite nice to know the timeline of things and actually try and build those cross-curricular gaps as well. So let me know if you study GCSE history. I personally did, and I very much enjoyed it. So, hopefully this bit of information you found interesting for your own studies as well. But let's get started in what you need to know for science. So what actually is the Haber process? I kind of alluded to this, but it's all this idea of nitrogen fixation. So nitrogen gas and hydrogen gas essentially chemically combining together to make ammonia. Now you can see this in the reversible reaction you have here. So we have N2G. G just means the gaseous form of nitrogen. So you can see we've got gaseous nitrogen, gaseous hydrogen, and this makes NH3. NH3 is the ammonia, okay? And because we're looking at all non-metals, these are covalent bonds that are formed between these chemicals. Also notice the arrow, okay? It doesn't look similar to a normal reaction arrow that's just straight forward. You actually have two arrows pointing in the opposite direction, which tells us there's a forward reaction and a backward reaction. This is what we call a reversible reaction. Essentially, this reaction that goes in the forward and backward direction will reach a natural dynamic equilibrium. So they're happening at the same time. Now, I haven't done a huge amount of content on reversible reactions, but I definitely can, especially stuff to do with Le Chatelier's principle, which I know a lot of higher tier triple scientists you guys need to know. If you'd like me to prioritize those videos, definitely let me know in the comments section and I will get that done for you guys. So if we look at this process in industry, how does this actually work? So we have the two gases coming into a big industrial vessel, if you will. And the first vessel, it goes into the first container, it's called a compressor. And this essentially has very high pressure, 200 atmospheres of pressure, to compress those gases into a container. Now, the reason for that is to make them react together. Remember, they're gases, they're moving around, those particles are free to move, and we want them to collide together. So if we compress them, that added pressure actually causes them to physically move closer together and more frequent collisions to occur. Now, this doesn't really do everything we need to. We still need to add a few more conditions to help this process. So what we do is we also increase the temperature to 450 degrees. Now, in terms of an industrial process, this is actually a lower temperature because, and we'll get onto this, the forward reaction is exothermic. We actually want to ensure that that is favored. So we have to reduce the temperature slightly. A bit of a misconception, I know, because 450 degrees Celsius is 4.5 times hotter than boiled water, for example. So it's very, very hot. But that's just something to be aware of. I will talk more about that in a moment. But you can see if they ever ask you what conditions are needed, high temperature, high pressure, you can give those figures as well. And an ion catalyst as well. Now, a catalyst is used, but it doesn't necessarily change the chemistry. What a catalyst does is it speeds up the rate of a reaction, how quickly that reaction happens. So remember, we've got a forward and a backward reaction. So they happen now at the same rate, but they're at an increased rate. We also know that the ion catalyst won't get used up and it reduces the activation energy. So how does that, or what does that mean? A reduction in the activation energy is the minimum amount of energy needed for a successful collision. So if we reduce that energy requirement, that means less energy is needed for those collisions to occur, which is actually more efficient. And that leads nicely to temperature, because if we increase the temperature to 450 degrees Celsius, those particles can collide more frequently because they have more energetic components to them. They're more energetic because of that temperature increase. So all of these conditions, like I said, the pressure, the temperature, the catalyst, all help with the reaction to speed it up. So what happens as a result? They've all collided together. Wonderful. The gas then gets condensed and it cools down. And because it's cooled down, it becomes a liquid and ammonia is formed. That gets tapped off and we can use it for fertilizers, which we'll talk about in a minute. However, what's so amazing about this process is if any of the unreacted gases, the hydrogen, the nitrogen, don't react like I say, they go back into the process again, and this gets recycled and recycled and recycled until all of the products are made from the reactants. So really efficient process. So this, of course, the Haber process is a reversible reaction, as we've said, and you do need to know how this links to the different conditions that are needed, but also specifically how those conditions favor the production of ammonia. I will do an entire video on reversible reactions, and I'm smiling a little bit because I feel as though this is a bit of a reoccurring theme in this video. I'm going to make more videos on this video. Videoception, it's all just kicking off with lots of videos that I still need to make, and definitely will. So do subscribe. But yes, reversible reactions and rate of reactions is a whole topic in itself. But I did want to mention this to you guys because this does link nicely and it does make the content make a bit more sense if I do explain it. So in the case of a reversible reaction, we have something called a dynamic equilibrium. We have a forward reaction. In the case here, nitrogen plus hydrogen makes ammonia. And we also have a reverse backward reaction. So we have ammonia breaking down into hydrogen and nitrogen. So those two things are happening at the same time. We, of course, in the Haber process, want ammonia. We don't really care about nitrogen and hydrogen. We just want ammonia. So how do we do it? Well, scientists understand the laws of pressure and how increasing the pressure can actually increase the yield of ammonia. But how does this happen? Well, it's all to do with the number of molecules on either side. So on the left-hand side, we have 1 nitrogen and 3 hydrogens, so 4 molecules on the left-hand side. On the right-hand side, we have 2 molecules of ammonia. So there's a 4-to-2 ratio, as you can see, if we think of it in that sense. Now, because there are more molecules on the left-hand side, if we increase the pressure on that gas, the equilibrium actually shifts to the side with less molecules. So there's essentially more space for those molecules. And that means the equilibrium shifts to the side that favors the ammonia. So more ammonia is made as a result, which is what we want. Now, we also have another condition, and the condition is temperature. Now, the forward reaction is what we call exothermic. So it releases a lot of heat energy when we add nitrogen and hydrogen together to make ammonia. The reverse of this, the backward reaction, is endothermic. So heat energy is absorbed. Now, what we can do is we can actually decrease the temperature on this reaction to 450 degrees Celsius. Yes, I know I said 450 degrees as if that's cool. It's hot, but we're decreasing the temperature to that point. And this actually shifts the equilibrium to the exothermic side to counteract the change in temperature decrease. Because if you think about it, if you're decreasing the temperature, the opposite of that is to increase the temperature. So we favor the exothermic side, which is why the equilibrium shifts to the side that has the ammonia production, and that therefore increases the yield. Like I said, I will do a whole video on this. So if you're not sure and you've never heard of this, or you've never heard about Le Chatelier's principle, which is what I'm discussing and referring to, don't worry, I will do a whole video on this. Just let me know in the comment section and I can prioritize that for you. Something else to mention here, because someone I'm sure will ask, is the condition, the catalyst. Of course, we do know that a catalyst is used in this reaction, specifically an ion catalyst. But remember, a catalyst just increases the rate of reaction. So the forward and reverse reaction will increase in rate. And therefore, we don't necessarily discuss the catalyst in this case because both versions of the reaction increase in speed, increase in the speed at which it happens. So there's no real shift there. It's just both sides increase in how they happen. So when you ever get asked anything about reversible reactions, these are the two things that they're talking about. So what do those fertilizers do? Now, I am going to make an entire video on this because there's a lot to know about NPK fertilizers, which I know sounds riveting. I know you guys are super excited about the video. I'm super excited about NPK fertilizers. If you weren't sure, that's sarcasm there. It's not the best topic. I'm sorry to say, it's not my favorite thing to teach. However, I will say this, it's a very, very useful topic because without these chemical processes, all the crops, all the agricultural farming techniques, they wouldn't be as efficient as they are without this process, because those fertilizers help crops grow and therefore increase the productivity of produce. So increasing the yield, it helps feed the planet. It is actually a very important process. But there is a lot of content at GCSE they like you to know. So I will make a whole video on that. That is more for the triple scientists of you out there. So if you would like that video and that applies to you, do let me know and I'll get on that. Anyway, so what do fertilizers do, just broadly speaking? They, like I say, help plants grow. But how do they do that? Well, specifically NPK fertilizers contain nitrogen, phosphorus, and potassium. Remember, potassium has the symbol K. These mineral ions essentially replace anything that is lost in the soil in terms of mineral ions. And those soil mineral ions will be absorbed by the root hair cell of the plant, and they will help the plant essentially do its job. So for example, potassium, those potassium ions essentially help with enzyme activity. The phosphate, for example, in the DNA that we know of, that phosphate backbone is made from phosphorus, so it can help with DNA and RNA and making that double helix. Nitrogen, for example, is found in chlorophyll. All of these mineral ions have a really great use in plants, and that's why we have to give those plants those minerals. Now, you might be thinking, doesn't the soil just contain them? Absolutely. But if you think about a farm that has lots of crops, there's an element of competition between those plants. So sometimes the soil will contain those minerals, some plants will take them up, but not all plants will get the required amount. So sometimes farmers will put on fertilizer in the soil to help encourage that growth of all plants. And this therefore increases crop yield. Like I said, I will do an entire video for all you guys on NPK fertilizers. Do let me know in the comment section if you'd like me to prioritize that one. And that's it from me today. I've been the GCSE science teacher and you have been curious. If you did enjoy this video, please do give it a thumbs up, share this with someone else to help them out, and do subscribe as well. Thank you so much for all your support and choosing to revise with me. It really does make a difference to your GCSEs when you learn a little bit every so often. I do make videos every Sunday. Please do come back and see the next one. Do click the bell so you get notified and don't miss it. And yeah, if you have any questions, queries, video requests, as always, feel free to comment in the comment section too. I also have an Instagram and TikTok. Everything is at the GCSE Science Teacher. And I hope you have a great day. Take care.